previous lecture, we considered a case where I have a cavity with mirrors on two sides with reflectivity R 1 and R 2 and light going back and forth. And what we showed is that if N 2 minus N 1, that is the difference in the density of atoms in the upper level and the lower level, is greater than minus log of square root of R 1 R 2 over sigma L, where L is the length of this cavity, then the light gets amplified. Light which comes out of here or here would be amplified. How do we achieve this? Because number one, remember, recall from Boltzmann's formula that the number of atoms in the upper level and number of atoms in the lower level, which will be same as their density also, is e raised to minus delta E over k T, which is always less than 1. So, thermally it is not possible to have N 2 greater than N 1. So, let us conclude thermally. That means, if you raise the temperature, right, it is not possible to have N 2 greater than N 1. So, something else has to be done, and that is what is done in a laser. And what happens then is the light which comes out through stimulated emission has exactly the same properties that makes it come out. So, photon that is coming in has exactly the same properties that is the photon that makes it come out, and therefore, this light has special property which I will discuss at the end of this lecture. But right now, let us consider how do we achieve N 2 greater than N 1. So, this is a brief introduction to the laser action and the related technology. Right. For more details, you may want to read advanced books. So, now number 1, in a 2 level system, we cannot achieve N 2 greater than N 1. Why? Suppose there is a 2 level system. More I pump to upper level, the more atoms come down. So, I can never achieve a situation where N 2 would be greater than N 1. So, in a 2 level system I cannot do that. So, one goes beyond 2 level systems. So, go to a 3 or 4 level system. So, in designing a laser, I have to choose my material properly, so that there are these levels, and now I am going to show you what kind of properties they should have. So, suppose I have a 3 level system, 1 level, 2nd level and 3rd level. What I can do is shine light of this frequency between the 1st and the 3rd level, so that a lot of atoms come here, and choose these levels in such a way that as soon as these atoms reach the upper level, they come down very fast. What that means is lifetime of level 3. So, I am going to name them now level 1, level 2, level 3 against decay to level 2 is very short. And when I say very short, that means this is slow, 2 to 3 is slow. So, that means much less compared to lifetime from 2 to 1. As a result, what would happen? These atoms that go to the upper level immediately come down here. So, they are getting depleted from here, lot of levels are being pumped up, and there will be a N 2 and N 1 would be such that I can achieve a condition where N 2 is greater than N 1. So, N 2 greater than N 1 is called population inversion. You have inverted the population from what normally happens in thermal case. Other possibility is 4 levels. You have 1, 2, 3, 4, and what you do here is let's label them 1, 2, 3, 4. Pump atoms here and make this fast transition, make the lower transition fast, and this is slow. So, what is going to happen? As soon as the atoms reach level 4, they are going to come down to level 3, and slowly they come down. As soon as they come down to level 1, and therefore, there is a possibility that number N 3 would become greater than N 2. So, wherever this slow action is taking place, those are going to be the levels for which I can use to amplify light. So, in a 3 level system, this is fast and this is going to be laser action. So, laser is going to be of the frequency corresponding to level 2 and level 3. In a 4 level system, this is fast, so is this, and the level in the middle are going to be laser. So, laser frequency is going to be corresponding to the frequency between these two levels. So, this is how population inversion is achieved. So, population inversion which is a new word now you are learning, is achievable in a 3 level or 4 level system, but not in a system that has only 2 levels. There, no matter what you do, you cannot achieve that. And once you do that, so I have this cavity in which I am doing this population inversion of atoms, and suppose I have achieved this population inversion, that means I have achieved N 2 minus N 1 greater than minus log of root R 1 R 2 over sigma L, where L is the length. Then as light goes back and forth, it is going to get amplified, and the light which comes out is going to be that amplified light. And these have special properties. What are the properties? Notice number 1, since the mirrors are parallel to each other, whatever light comes out is going to be highly directional. Any light that goes like this is going to be lost. So, property number 1, and this light which is coming out is laser. Laser means light amplification by stimulated emission of radiation. So, one property is going to have is it is highly directional. Why? Because you are amplifying the light going in one particular direction, so it is going to be highly directional. And also it is so because its spread is minimum possible that is set by the diffraction limit. So, it does not spread like a torchlight, it spreads very little. And 3, and that also happens because it is highly coherent. That means the relationship between phase on different points on the wave front, which is known as the spatial coherence, and temporal coherence, that is the relationship between phase at one time and the other time, they are very, very stable, and all these 3 properties make it a very special light. Let me just mention what is this diffraction limit. This is given by theta equals lambda over d. This is the minimum limit, where d is the aperture size, lambda is the wavelength, and theta is the spread angle. So, this is the minimum spread that is set by the diffraction, and laser follows this. That means, if I take a laser beam which is of diameter d, it will spread by angle theta, which is of the order of lambda by d. All other lights spread much more because they are not coherent. So, these are special properties of lasers. So, just to conclude this lecture, using stimulated emission, light can be amplified by passing it through a medium with population inversion. Right. 2, critical population inversion density, inversion density is given by minus log square root of R1 R2 over sigma L, where L is the length of the cavity. 3, inversion is achievable in 3 or 4 level systems, but not in a 2 level system. And 4, laser which comes out of this amplification is special light that is highly directional. Laser is a light which is highly directional, coherent, has minimum possible spread set by the diffraction limit, and also one thing I forgot to mention is highly monochromatic. That means one frequency. It has one frequency that corresponds to that transition frequency, although there is going to be some spread, but it is highly monochromatic compared to all other lights. So, that is the special properties of lasers. So, with this I conclude this technological application of lasers. Keep in mind that the idea was proposed way back in mid 1910s, so 1915, 1914, but the first maser and laser was made in 1960s. So, technological advancement had to wait about 50 years after the idea came. Next, we are going to start in the next week the build up to quantum mechanics, and I am going to start with correspondence principle in the first lecture next week.